Hello guys, this is your NBS sir. Let me present the question number 25. A 200 microampere current galvanometer deflects by pi by 3 radian. For what value of current it will deflect by pi by 10 radians? So we understand that a galvanometer basically works that the angle that needle makes, the angle made by the needle is proportional to the current that enters the galvanometer. So if current entering the galvanometer is proportional to the angle deflected by the needle, I would say that I1 by I2 is equals to theta 1 over theta 2. I1 is given in the question 200 microampere, right? They are asking you to calculate I2 and the angle made by the needle for I1 current is, guys, pi by 3, and the angle for the current which they are asking you to calculate is pi by 10. Now from this expression you can calculate the value of I2. Let's go to the next question. Two charges of minus 4 coulomb, 4 microcoulomb and plus 4 microcoulomb are kept at certain positions and in presence of the external electric field. So they have given you the coordinates. Now they are asking us to calculate the torque basically, and I remember the torque is calculated by the formula P cross E, right? So for that you are supposed to get the dipole moment vector. Electric field is given to you. Now how to get the dipole moment, vector? The charge number 1 is given as 4 microcoulomb. This is plus 4 microcoulomb, and the position coordinate for minus 4 microcoulomb is given as 1, 0, 4, and the second position is 2, minus 1, 5. As we know, these two pair of charges makes a dipole, and the dipole moment is like this. So the vector of dipole moment is going to be the magnitude of dipole moment into this vector, and this vector is the unit vector of the position vector from minus 4 coulomb to plus 4 coulomb, and then we'll get the unit vector for this. So our unit vector is, let me get the value of our unit vector. This is 2 minus 1 I cap plus minus 1 minus 0 j cap plus 5 minus 4 k cap. So this turns out to be I cap minus j cap plus k cap and divided by the modulus root 3. So this is your unit vector. And what is going to be the magnitude of dipole moment, guys? Magnitude of dipole moment is going to be the magnitude of charge that is given as 4 microcoulomb and distance between these two. So the distance between these 2 points is root 3, right? So we have got the dipole moment in terms of the vector. We already know the E vector. If you calculate this and take the modulus, you will get this answer. Let's go to the next question. A nucleus with atomic number 50 and having radius 9 into 10 raised to power minus 13 centimeter. We are supposed to calculate the potential in megavolt at the surface of the nucleus. So the total charge that is inside the nucleus is, the total charge is Z into E. Z given to you is 50 and E is the charge of single electron, that is 1.6 into 10 raised to power minus 19 coulomb. So the formula that I will be using to calculate the potential at surface is KQ total divided over radius. Let's place the values. K, we already know the value, 9 into 10 raised to power 9. Charge given to us is 15 into 1.6 into 10 raised to power minus 19, and R is 9 into 10 raised to power minus 15 meters. You solve this, you will get the answer. The next question is, a pressure inside a wall pipe before hole is 4.5 into 10 raised to power 4 Newton per meter square. When a small hole is made in a pipe, pressure changed. If the speed of the water flux after hole is root V meter per second, we have to calculate the speed of efflux. Now suppose this is our beaker, right, filled with the liquid, and this is the point where they are making a hole. Okay, before making the hole, the pressure given to you at this particular point P is, its P initial given to you is 4.5 into 10 raised to power 4 Newton per meter square. After making the hole, the pressure given to you at the same point is 2 into 10 raised to power 4 Newton per meter square. And as we can see, there is a little correction. They should have given the pressure outside the hole. But as the data they have given in the question, we have to solve it accordingly. So the speed with which the fluid is going to come out is, we are directly going to use the Bernoulli's principle. And with Bernoulli's principle, I can relate it, because I am applying the Bernoulli principle for two inside point and outside point. So the change in pressure, I can directly write this as, is going to be equal to the kinetic energy of the fluid that is coming out, right? If you directly put the value of delta P, you will get the answer. Thank you.